Alright, so for our capstone, we decided to make a old-style arcade game where targets flip up, you shoot them, they flip down. We wanted to use a infrared light in order to activate them, and we wanted them to be randomly popping up using a microcontroller to do so.
Okay, there's several parts of the game. We decided to make there's obviously the targets that gotta flip up, there's the score, there's gotta be a time. We also gotta have a gun to shoot it with. Next slide. Sensor circuits, it was really complex because, I mean, we end up having, we have a motor, we have a sensor, we end up having a timer, we end up having a counter. They all gotta work together. So in the end, it really came down to tying it all together. We decided to use the 8051 microcontroller processor to control both the time and the score. We had to use two of them, mainly because there's limitations on the processor. One of the controls for the scoring and flip, so one controls the flip, score, hit, and then the other controls the time of the duration of the game. We decided to use the C language instead of the assembly language, mainly because we're pretty familiar with it. We had a class in it, so. But some of the complex workings of the 851 made it really interesting using the C language with the processing. One of the main issues that we had at the beginning was we didn't have to configure the inputs with the C language. We ended up there's a special way of doing it. We only do assembly, and so we really had to figure that out before we could actually start the whole program. This here is the timer circuit. We used an 851. We used BCD drivers for the 7-segment displays, and we just used 4 outputs off the 851 for each driver, and we ran the TTL drivers to the displays with the processor. The gun, we purchased the gun at Walmart, I think. We got the gun, we did some modifications to it. After the modifications, we used the trigger, and we put some IR sensors, or IR LEDs in there, and that's what we would use to fire against our targets. Components of the gun, there's obviously IR transmitters. We ended up tried to use an ultra bright LEDs for testing purposes, trying to hone it in, but in the end, it didn't pan out for us. The gun design, we ended up having to put a timer because we had to pulse with an IR LED at pulse at the frequency was 56K. We had to use 56K because that's what our transistors were that are reading the target. That's what they were sensitive to. So we had to obviously create an oscillator. We used the 555 for that. When we bought these, well, the issue we ran into is the target design. We really wanted to come up with something more of a DIY in a home, but we ended up finding out that we looked at solenoids and doors and trap pop-ups, and we ended up finding that to get something with enough throw and enough power that wouldn't take tons of current. We were looking in the $30 range, if not more. The stuff we found in the lower range just didn't work. Then plus we had to build a contraption for the door and the flip. But we found these targets, these motorized flips on the internet for half the price. So all we did is we bought them, took out the microprocessor in it, and just used the motor and put our own sensor in. And in the end, all we used was the mechanics of it. That's all we bought. We bought the we took the transistors out of the targets that we bought, and we put our own in that would match the LED that we decided to use. And the receiving target.
The receiving target, we really couldn't find any schematics for it on the internet, so it was just a lot of tweaking to try to get it to work. We ended up having to put just a couple capacitors and a couple resistors together, and it actually turned out to be a pretty easy little circuit to get going once you figured it out.
I made up the drivers. We needed drivers to run the motors because coming out of the microprocessor, we've only got 1 milliamp, 1 milliamp coming out of the outputs of the drivers. of the microprocessor. So we needed a driving circuit to be able to pull up enough current so we can actually make the motors actuate. We first designed it off of 5 volts, and then we ended up switching to 12 volts because we found out that 5 volts just didn't give us enough power. We were having a problem with them not coming up quite all the way, and if you don't have them come up all the way, then your IR isn't going to shoot in at the right angle, and you're not going to be able to sense it. This is the circuit. Basically what we had is we had to make a pull-up resistor because the output of the processor just didn't have enough to trigger the motors to actuate. But yeah, that was a pretty simple design, really.
Yeah, let's do it. Skip on it though. Kind of random actually. It's going. I like it. Sound effects. I like it. Wait. I do actually.
I was really liking those 4.
That one brand is burn on. I got one right there. Sorry.